In this lesson we're going to look at solving square root inequalities. We solve square root inequalities in much the same way as we solve square root equations. So if you need a little review of that or need to learn how to do that, you might want to look back at solving square root equations at that lesson first. But if you're familiar with solving square root equations, then we're going to solve square root inequalities by still isolating the square root and then squaring both sides and then solving the resulting inequality in the same method you would solve the inequality for whatever type of equation that turns out to be. And so we're going to attempt to do that with some simpler ones in this video, and then I've done a second lesson, it will be called Solving Square Root Inequalities number 2, that will do a few more complex examples. So let's take a look at this. One of the things that we have to do besides just isolating, squaring, and solving is we first have to take into account the domain that we have in our problem, because we don't want any numbers to appear in our solution set that will cause this x plus 7 in this case, the part that's under the square root, to become a negative number. Because if we allow that to happen, then we'll have an answer that will not get a real answer, or we'll have a number that will not get a real answer because we can't take the square roots of negative numbers, and we don't want that. So when we're doing these problems, one of the things that we'd like to do is we'd just like to go over to the side somewhere, and then when we get over to the side, find us a place and just figure out what our domain is, and that's easy to do. I'm going to go over here and I'm just going to say x plus 7, which is the part under the square root sign, has to be greater than or equal to 0, meaning it's got to be positive. As long as it is, everything will be good. And I'm just going to solve that simple little inequality, which means it's going to be x is greater than or equal to negative 7. So as long as any answer I get when I solve the problem on the left side is greater than or equal to negative 7, then I'll be able to use the entire solution set. If not, I may have to limit my solution set based on this domain of x is greater than or equal to negative 7. So that's where we're going with this. I'm going to put a D right there to identify that as my domain. Now I'm going back to the left side. I'm going to solve this in the way I would solve any square root equation, which is I'm going to isolate the square root. Well, it already is. Everything on the left is under the square root sign. So the next step is to square both sides. So I'm going to square this, and I'm going to square that. So that gets rid of the square root sign, leaving me x plus 7 on that side, and 3 squared is 9. And all I have at this point is a square root, not a square root, but a linear inequality, which is the simplest kind to solve. You solve linear inequalities just like a linear equation, except if you ever divide or multiply by a negative number, you have to flip the inequality sign over. So this time, I don't have to do that. I'm just going to subtract 7 from both sides. So 7 goes away on the left, 9 minus 7 is 2. And that is my solution, as long as it doesn't cause any numbers in the solution do not violate the domain that I established on the right side. So I look at it. X is greater than or equal to 2. Are there any numbers greater than or equal to 2 that are also greater than or equal to negative 7? Well, no, there isn't. That is my solution then. X is greater than or equal to 2 because all of the numbers in the solution are acceptable as far as the domain, as far as the x's that I'm allowed to use. So x greater than or equal to 2 is the solution to this one. Let's take a look at another one here. Alright, this time we have an inequality, square root of x minus 4 less than or equal to 5, that I need to figure out my domain on. So again, I'm setting it greater than or equal to 0 because I want to find out what x values would cause this to be negative, and that's something I don't want. So as long as my x values are greater than or equal to 4 in this case, that's my domain, then all of my numbers in my solution set are acceptable. Now I'm going back to the left side. Again, I'm going to square both sides. That gets rid of the square root sign. and 5 squared is 25. And it is another linear inequality, so I solve it like a linear equation. I add 4 to both sides, and my solution says x is less than or equal to 29. So I have to look back at my domain again. Are there numbers less than or equal to 29 that are not greater than or equal to 4? Well, in this case, yes, there are. I mean, numbers like 0 or 1 or negative 10, they're all less than or equal to 29, but they're certainly not greater than or equal to 4. So I have to limit my solution set to only numbers that are bigger than or equal to 4, but at the same time less than or equal to 29. So I would write my answer like this. I would say that x has to be between 4, and I included 4 by putting the equal under the less than, 4 and 29, and including 29. That is my actual solution. If you like writing it in interval notation, use a bracket to show 4 is included, and then 29 on this side, also with a bracket to show 29 is included. So I've used my domain to limit my solution to all of those numbers that would prevent me from ending up with a negative under my square root sign. So this is how you solve a relatively simple square root inequality, one that turns into a linear inequality, using the domain. You always have to look at domain here. If you want to know how to solve a more complex one, one that perhaps will take more than one square root sign, or that will end up as a quadratic or a square root function whenever you solve the inequality, go to the next lesson, which is solving square root inequalities number 2, and we'll do a couple of examples of that one. I invite you to look for other lessons, even on other topics, at mymatheducation.com or on my YouTube channel, Mymatheducation. Thanks for watching this one. Hope you'll come back and take a look at the other things we have if you'd like more information on how to solve common algebra problems. Thanks for watching.